All right, guys, I want to take some time to outline how we are going to do an example for one of these horizontal projectile problems. So let's imagine a ball is thrown horizontally off a 15-meter high building with a velocity of 8 meters per second. How far away from the building does the ball land? Now, a couple things I would probably change with the writing of this problem. Thing one, I would probably make it, I'd probably express explicitly that this velocity is a horizontal velocity. It's launched horizontally off of this building. Thing two, instead of how far away from the building does the ball land or how far away from the base of the building, I would like to use the word range to make it clear that we are looking for the distance in the x direction. So when we do one of these problems, the first thing we want to do is we want to draw a little picture, just showing ourselves what we should be looking at in our mind's eye as far as completing this problem and setting up data. Okay. All right, so we've got our building. Okay. Got our little door, right? Perfect, okay? First thing I want you guys to do is to set up a T-chart, okay? It's going to be an XY chart. Now, the reason why we set up this T-chart is because objects that involve are on the X side belong on the X side and are only calculated with physical quantities on the X side. And stuff that's on the Y stays on the Y, right? The Y and the X don't influence each other. The only thing that belongs in the middle is time. Because time is the one thing both sides have in common. So typically the format of these problems involves the fact that you're using one side to solve for time and then using time on the other side. So if we were to take the two givens that we know from this, we know that our y, our vertical distance, is 15 meters. And we know that our v naught x is equal to 8 meters per second. From here, we're going to start filling in some hidden givens, okay? Hidden given number one, because this is a horizontal velocity, a horizontal projectile problem, there is no vertical velocity component. So my v naught y is 0. When I use the word component, I mean part. There's no part of this velocity that belongs in the vertical section. So I'm starting with v naught y is 0. Similarly, I know from my free fall problems that my acceleration vertically, ay, is 9.8 meters per second squared. And guys, I'm making an assumption here with ay and y. This assumption is if both these numbers are positive, then down must be positive, okay? I'm going to say down is positive for now because my problem is set up in a way that it allowed me to. But if I were to say that down is negative, 9.8 would be negative and 15 would be negative, okay? The other hidden given is, because I have not attached rocket boosters to this ball after it's been launched at 8 meters per second, ax is 0 meters per second squared. So I've got my hidden givens, okay? I've got my normal information. And from here, guys, we're going to be using either one side or the other side to find time so that we can solve for what we're looking for. What are we looking for again? We are looking for the displacement in the x direction, okay? How far away from the building does the ball land? And again, I would probably use the word range if I was asking you on a test or quiz. So our game plan, okay? Just looking at what the information that I have here in this specific question, it looks to me like I have enough information in the y in this case to solve for time, and then once I have time, I can solve for the x direction. My x direction is always going to be some sort of form of v is equal to d over t. Because I'm never accelerating, this is always going to be the case, okay? Okay, so because I'm missing my d technically, and because I'm missing my t, I better solve for that so I can solve that side. All right? I have y, I have v naught y, I have ay, I'm looking for t. So this seems like a safe bet for the formula. Make sure when you write out this formula, you don't forget the squared at the end. That's one of the most common mistakes I see. Plug it in, plug it in. Okay? Notice for a second that if I said that down was negative, it's important that you don't just make the 9.8 meters per second squared negative, you also make the distance negative. Because eventually when you divide these two numbers, you should be getting a positive number, so that when you take the square root, you don't, run into some pesky math issues. Okay. If memory serves, time is 1.76 seconds, or somewhere around those lines. All right, so now we can plug that in. So I've got a V for this formula, I've got a T for this formula. Let's solve for my distance. Again, if memory serves, I believe this is like 14 meters. Okay? So that's an example of how we would do one of these horizontal projectile problems. I don't think individually they are very hard. The hardest part about a horizontal projectile problem is staying organized, identifying and labeling your variables properly, and then continuing to stay organized in your thinking as you begin plugging in physical quantities. Remember, you should never be plugging in X quantities with Y quantities in any of these formulas, because they don't affect each other. They don't belong in the same equations. So that's where all our work with our subscripts and identifying that, hey, sometimes distance is X, sometimes distance is Y, and it depends on our perspectives, okay? This is where all that begins to pay off and make sense, all right? Okay, good luck. Let me know if you have any questions.